Welcome to Physics World Online College, where we explain to you the concepts of physics and makes it very simple for you to understand and also for you to excel in your exams, be it WAEC, NAPTEP, NECO, and any other standard exams you may have that require these topics. Now, in our class of today, we shall look at arrangement of capacitors. Please remember to subscribe if you have not done so, and also to share this class video with your friends on the various social media platforms. That would be a nice thing for you to do. We'll continue. So we say another name for capacitor is condenser. And we say the capacitor stores electric charges. Good. So we can actually combine capacitors in two forms. Either we have them arranged in series, or we have them arranged in parallel. For this class, we will discuss just series connection, while in the next class, we'll talk about parallel connection of capacitor. So I said the arrangement of capacitor is divided into two, namely series arrangement and what? And parallel arrangement of capacitor. So this is one, this is two. We will take the first one in this class, like I said earlier. So series arrangement of capacitor. We will have a circuit diagram where we shall connect three capacitors in series. Now, how do you recognize series arrangement of capacitor? The capacitors are put end to end. Look at it. Remember, this is the circuit symbol for capacitor, equal length of the lines or the terminals. So if this is the positive terminal of this capacitor, this is negative terminal of this capacitor, the negative of the first capacitor is connected to the positive of the second capacitor, while the negative of the next capacitor is connected to the positive of the other one. So that is how we know series arrangement of capacitor is connected positive, negative, positive to negative, positive to negative. That tells you that the capacitors are arranged in series. Now, let's say the capacitance of this capacitor is C1, of this is C2, and this is C3. Now, if we connect a voltage source across these three capacitors, so let's say this is a cell or a battery. This is a terminal of the cell or battery. Now, the voltage that will flow, that will come out from this cell, let's call it V or V subscript V. That's the total voltage or equivalent voltage. Now, once this battery is connected across the capacitor, charge will what? Begin to come out of it and be stored in the respective capacitors. Now, when the charge reach this capacitor, there will be a voltage drop across this capacitor. We'll call it V1. When the charge in this one, second capacitor, we have a voltage drop there, V2. And then for the third capacitor, we have what? a voltage drop across it, which is V3. Now, the charge that will be stored in each of these capacitors, let's call it QT. That's a Q total. Now, one other attribute of series arrangement of capacitor, I've said in the first one before I mention the second now, that how do you recognize them? The terminals are connected positive to negative, positive to negative. That's one. Now, I'm saying another point about series connection. Now, the capacitors will have the same charge. So the charge in each of the capacitor is the same. So let's take note of that. For series arrangement of capacitor, one, the capacitors have the same charge. That's how we know them. And that's one quality you must know about the series arrangement, and it's often used in solving questions. They have the same what? Charge. Same charge. Stored in each. Same charge. What does that mean? It means that the total charge QT is equal to the charge in the first capacitor Q1 is equals to the charge in the second capacitor Q2 is equals to the charge in the third capacitor Q3. So the charges are the same, which means in a typical question, as they normally ask, especially in JAM, they can give you the charge across one of the capacitor. It means if the charge of that capacitor is given to you, is the same charge for all the other capacitor, one for all. So if you know one charge, then you have known the charge for all of them, because once they are in series, they have the same charge. That's one point. Number two, as I said, here they have different voltages across each of the capacitor. So I say the potential difference across the capacitor is, okay, let me say differences are not the same. So while they have the same charge, they have different what? Voltage drop. Why? Because they have different capacitances. Good. So what does it mean? It means if I want to get the individual voltage drop across each of the capacitor, then this is what I will do. If I'm getting V1, it will be equal to the charge over the capacitance of Q1. Now, this charge, let me say QT, because QT is Q1, or let me use this. So Q1 over C1 is equals to, I replace Q1 with QT because they are all the same, equal to C1. This will give me the voltage drop across the first capacitance. Likewise, V2 will be Q2 over C2. I replace Q2 with QT, being the same, over C2. Then V3 is equals to Q3 over C3, which is what? QT over what? C3, which means actually the V total voltage is the total charge over the total capacitance. Good. By the way, where does this formula come from? It comes from the definition of capacitance we studied in the previous class. So you go back there and you see. Let me just recap. I told you that capacitance is the ratio of charge to the voltage. So if I make voltage the Pareto formula now, I will have what? Charge over what? Capacitance. So that's where that formula is coming from, just to let you know. Okay. Now, I said with this, we obtain the individual voltage drop. So in questions where they want you to find the individual voltage drop, then this formula will help. Now, another point you need to know is this total voltage from the battery, from the source, is equal to the individual voltage drop added together. So that is, the sum of the individual voltage equals the total voltage. I say that the sum, or let me say it this way, the equivalent or total potential difference is the sum of the individual potential differences. Now, I translate that into mass. It means that the total voltage Vt is equal to the individual voltage V1 plus V2 plus V3. Now, I will substitute the individual voltage inside the formula. So this will give me Vt. As in place of V1 now, I will put what? Qt over C1. In place of V2, I put Qt over what? C2. In place of V3, I put Qt over what? C3. So I've used the individual formula to replace this. Then, in place of Vt, I can actually put Qt over what? Ct as well. So that gives me, I can factorize the Qt out. From here, I have Qt equals 1 over C1, 1 over C2, 1 over C3. So you will see that Q and Qt are common, so they will eliminate. Or I can rearrange this one and represent it as Qt1 in brackets. Good. So this Qt divide what? Qt, and it cancels out. So I'll be left with what? Therefore, 1 over Ct is equal to 1 over C1 plus 1 over C2 plus 1 over C3. So this becomes a formula for calculating the total capacitance or equivalent capacitance when you have capacitors arranged in series. So you take note of that. Now, so the fourth point here is saying that the reciprocal, that is 1 over Ct's reciprocal or inverse, the reciprocal of the equivalent capacitance is the sum of the reciprocals of the individual capacitances. So that is for you to take note of. So once you are told that the capacitors are in series, then the total capacitance, the resultant capacitance, the combined capacitance, the equivalent capacitance is given by that. You see, I've used different names which are often used by different authors. So whether they say equivalent, or they say total, or they say sum, or they say combined, or they say effective, they are saying the same thing. Good. So the formula has been established. With this, we can apply it to solve the given problem that we have on the board. So we're looking at that example. So solution to example. So we are told that we have two capacitors, 5 microfarad and 3 microfarad in series. So let's put a sketch there. 5 microfarad. So let this be 5 microfarad. So this is C1. Let this be what? 3 microfarad. And I put it here. 5 microfarad. This is C2, 3 microfarad. Okay. So we are told that they are connected across a battery of voltage 600 volts. So we connected it across a battery. This is the V total, which is 600 volts. So once this connection is done, then we can find the combined capacitance, which is CT. Now, since it is a series connection, I'm going to start with this, but there's something I want to obtain for you to take note of. So for series connection, to get the combined capacitance, which is option A, I will say 1 over CT is equals to 1 over C1 plus what? 1 over C2. Why did I not say plus 1 over C3? We have only two capacitors here. So as the number of capacitors given, you extend the formula. But when you have two capacitors connected in series only, then there's something special that you need to know, which I want to show you now. So I have that CT is equals to, I will take LCM of C1 and C2, which is C1, C2. C1 into C1, C2, we are left with C2. Multiply by 1, I have C2 plus C2 into C1, C2, I will have C1 times 1, that's C1. Now, this 1 over means inverse or reciprocal, like I said. So I can invert it. I will carry CT up divided by 1. Then I will carry C1, C2 up and divided by what? C2 plus C1. This one, I can rewrite it as this. C1, C2. This denominator, I will bring C1 first. C1 plus what? C2. What does that show me? It means if I have two capacitors in series only, that's the condition. It must be 2 and then they must be in series. Then I can use the product of the capacitances over the sum of the capacitances. We used to call it product over sum. So this gives you what? Product over what? Over sum. Like I said, it is used for two capacitance only connected in series. Is that clear? So let me note it somewhere. This formula is used for two capacitors connected in series only. It must not be 3 and it must not be parallel. So you take note of that. Then, so if this information is true, then we can substitute into that equation and obtain the capacitance as well as the other quantities they want us to what? To obtain or solve for. So now let's look at that. So I have CT, therefore, remember C1 is what? 5 microfarad. So I have 5 times C2 is 3 microfarad divided by the sum, which is 5 plus 3. This will give me what? 15 over 8. And when you divide it, I will have 1.875. It gives me 1.875 microfarad. Observe what I did here. In this product over sum, I'll use 5 and 3, which are a microfarad. That is why the final outcome is still a microfarad. Good. But we have said previously that the SI unit of capacitance is farad. Microfarad is just sub-multiple unit. So for me to use this capacitance to solve for charge or voltage if needed, or to solve for what? Energy stored, that we'll see in the future class, you must remove this micro sign. You cannot use it with this micro sign. They say you are wrong. So what does that mean? So I will have to re-express this as 1.875 times 10 raised to the power minus 6 what? Farad, before I can use it. I hope that information is noted. So let's take the next thing, which is to find the total charge. So we have seen the total capacitance. Let's look for the total charge that flows, that is stored inside. So we have QT is what we want to find. So to get the total charge, remember I told you that the charge is the same. I have the formula there. Good. So the total voltage is equal to the total charge over the total capacitance. Total voltage is known, 600. Total capacitance is known, this value I've calculated. So to find what? The total charge, I will cross multiply. So I say total charge QT is equal to, if you cross multiply, you have what? VT times what? CT. Or let me put it the popular way, CV. So CT times what? VT. Once again, I said this was obtained from the formula. Capacitance is the ratio of charge to what? To the potential difference of voltage. So if I cross multiply there, I will have Q is what? Is CV. So there are a lot of questions even on just this formula. So once you know the capacitance and the voltage, they say find the charge. And once you know the charge and the voltage, say find the capacitance. Good. So let's substitute now. I will have QT is equals to CT, which is 1.875 times 10 raised to the power minus 6 times VT, which is what? 600. Let me just, for the sake of emphasis, repeat. Since I want to obtain this total charge, it is wrong for me to use 1.875 alone, which means I have retained the microfarad. That is not acceptable. I must compulsorily remove that micro sign before I can use it in any other calculations. Let that point stick. So once you multiply, you will have that the value for the total charge is now equals to 1.125 times 10 raised to the power minus 3. SI unit of charge is what? Coulomb. If I want to remove this 10 raised to the power minus 3, I replace it with milli. But I'm not doing that because I need that charge in the next calculation I want to do. So C, we are asked to look for the what? To look for the voltage drop across the 5 microfarad capacitor. That's the voltage drop across C1, so which is V1. So I say to get V1, it will be the total charge. Where is it? V1, the total charge divided by the what? The capacitance of what? The capacitor of at that position, that's C1. So which means the voltage drop across the 5 ohm capacitor is V1 equals the total charge divided by what? C1. So I could have said Q1 over C1, but Q1 is equals to what? QT, since the charges are what? Are the same. So this will give me, once again, I couldn't, if I change this to my milli, then I cannot use 1.125 in this work. That will be unacceptable. I must remove it and express it in this format. So I have 1.125 times 10 raised to the power of minus 3 divided by the capacitance, which is 5 times 10 raised to the power of minus what? 6. Do you see that? So I must remove those submultiple form before I can apply them in this work. So when you multiply and divide, you get a voltage of 225 volts. That becomes the what? The voltage drop across the what? 5 microfarad. Of course, which means another question could have asked me to find the voltage drop across what? C2. Which means I will say QT divided by what? C2. I'll get that. Or since I have known V1 and I know VT, then I can what? Subtract, because I've said my V1 now is what? 225. I subtract 600, 225 minus 600, I will get what? V2. We're not asked, so I'm leaving it. So now you have seen the step and the formulas and the points for you to take note. Please, you will solve this class work 1 and 2 and submit to me. I will get back to you. Thanks for your time. Bye.